section is about adding and subtracting rational expressions. It's finding the sum and difference with rational expressions. I'm going to remind you about how to add and subtract fractions when they're numbers. Adding and subtracting is harder than multiplying and dividing because you have to find a common denominator. And then we'll do some rational expression work after that. So a reminder that my Halloween costume was going to be a fraction because fractions are scary. And the reason fractions are scary, I think, is adding and subtracting fractions when you don't have a common denominator. When you do have a common denominator, it means that you have 3 parts out of 75 plus 4 parts out of 75. And so you're just adding up your parts, but it's still out of 75. So you have 7 out of 75. If you have a common denominator already, you just use that common denominator. It gets hard when you don't have a common denominator. So here my denominators are 10 and 75. One way to think about making the common denominator is I can make sort of a Venn diagram, and I can think of all the things that multiply to make 10, and all of the prime numbers that multiply together to make 10. So if I did a prime factor tree for 10, I would just get 2 and 5. And so these are the numbers that multiply to make 10. And then I'm going to do that same thing for 75. 75 is 3 times 25, and 25 is 5 times 5. But when I put my numbers in my Venn diagram, anything that's in both lists, I put as an overlap. Both of these lists have 1, 5 as an overlap. So that goes in the overlap section. But this circle still multiplies to make 10, and this circle still multiplies to make 75. So once I have that done, and I've figured out what my factors are for each number, I've factored each of the numbers completely, then I can say, well, I would like this fraction, 3 out of 10, to have the common denominator, and the thing that it's missing, the thing that from the Venn diagram that it doesn't already have, is a 5 and a 3. So I'm going to take this fraction and I'm going to multiply it by 3 times 5 is 15. So I'm going to multiply it by 15 over 15. And the other fraction has everything except for the 2. So I'm going to multiply that fraction just by 2 over 2. So then I multiply it straight across and I get 45 over 150 plus 8 over 150. And I add and I get 53 over 150. And now I'm done because I found a common denominator so I could add my parts together. We're going to do that same idea when we're working with rational expressions. The kinds that are easy are the ones that already have the same denominator. So the denominator here is x plus 4. We analyze it, look at it, and say, yep, they're the same. So that means that our answer will have that same denominator, and we will just add the numerators together. X and 5 are not like terms, so we just write them next to each other, and here is our sum. This one, when we look at the denominators, we might think at first that they're different, but actually that first denominator is factorable, and we can factor it so that it looks like the other one. So we could write this as 2x plus 1 over, if I factor a GCF of x out, 2x plus 1 over x plus 3, and x minus 8 over x times x plus 3. Those are common denominators, which means that our answer will have that same denominator, and we just need to add like terms. So we have 2x plus 3x, which is 5x, and 1 plus negative 8, which is negative 7. Here's one for you to try, and they have a common denominator. So when you're done, you're going to add your like terms. So 10 plus negative 4 would be 6x, and negative 5 plus 8 would be 3. Now, If we don't have a common denominator, then we have to do that same process that we did with fractions. First, we have to factor our denominators, and then we write each fraction with a common denominator. We multiply by a special kind of 1 so that we can have a common denominator. Then we add the numerators, looking for like terms, and we might need to factor the numerator to see if the sum simplifies at all. So here's our first example. If I look at these two denominators, they are different, but I can factor x squared minus 1. It's a difference of two squares, so it's going to be x plus 1 times x minus 1. And I can factor x squared minus 3x plus 2. It has a product of 2 and a sum of negative 3. So negative 1 and negative 2 works. So this is going to be x minus 1 times x minus 2. So if I do put that onto my Venn diagram, they both have in common an x minus 1. The x squared plus minus 1 also has an x plus 1. And the other fraction also has an x minus 2. So if I look at my first fraction, which is x plus 3 over x plus 1 times x minus 1, the term that's missing from that is x minus 2. So I'm going to multiply this fraction by x minus 2 over x minus 2. This is the one that's missing from that first fraction. And if I look at that second fraction, and I write it in factored form, the thing that's missing from the second fraction is an x plus 1. So then I have to multiply, and this is where I have to remember, oh, I'm multiplying two binomials together. A lot of you like to make a box when you have to multiply two binomials together, so we would make a box for that. X plus 3 and x minus 2. If you like to distribute, you would be distributing these numbers together. And you get x squared plus x minus 6. And I'm not actually going to multiply out the denominator ever. I don't want to make things more complicated than they have to be. And so there's no reason to do that. And here we're going to distribute the 2. And as we look for like terms, we have x squared plus 3x minus 4. But we still have to do a little bit of thinking because maybe we can factor x squared plus 3x minus 4. So our product would be negative 4 and our sum would be 3. And yeah, that works if I use negative 1 and 4. So actually this factors even more. So it's x minus 1 times x plus 4. And what I notice is that we are going to have a factor that is in both the numerator and the denominator, so that factor will cancel. So our final answer, write it up here because I've run out of space, our final answer is going to be x plus 4 over x plus 1 times x minus 2. Here's another one to try. I would pause the video and give this a shot and then come back after you have tried it. So my process was I factored out both denominators. I noticed that both denominators had an x minus 2. The x squared plus 4 denominator also had an x plus 2 in it. And the other denominator also had an x minus 3 in it. So I multiplied the first fraction by x minus 3 over x minus 3. and the second fraction by x plus 2 over x plus 2 so that the denominators could be identical. And then after I multiplied out my numerator here, x plus 6 times x minus 3, I used a little scratch work over here, and I distributed the 2 through the parentheses here. Then I added my numerators. My numerators had some like terms, so I had to add those together, and then I noticed that my numerator here was factorable, so I factored that as x plus 7 over x minus 2. The x minus 2's canceled, and I was able to simplify my answer to x plus 7 over x plus 2 times x minus 3. When we do subtraction, we do almost exactly the same process, but instead of adding like terms, we will subtract like terms when we have common denominators. So for this problem, I'm going to factor. X plus 8. And I noticed that both polynomials have an x plus 2 in them. This one also has an x minus 8 in it, and this one also has an x plus 4 in it. So when I multiply them both, I do 1. The thing that's missing here is an x plus 4. And then, oops, this one is a subtraction problem, so it's not plus, it's minus. This one is x plus 2 times x plus 4, but the thing that's missing is an x minus 8, so I'm going to multiply by x minus 8 over x minus 8, so that I can get that back in there. We do either a box or distributing to get these like terms together, to combine those, to multiply those two binomials together, sorry. The other one, I am going to have the same thing. They both have the same denominator, it's just written in a different order, but it's multiplication, so I can do that in either order. And now I can turn this into addition by changing every single sign here, or I can just remember I'm subtracting everything. So x squared minus x squared would be 0x squared. 5x minus negative 7x would be 12x. And 4 minus negative 8 would be 12. So I have 12x plus 12 over all of these factors. So the difference here is I'm subtracting each of my terms rather than adding my terms. Okay. And also 12x plus 12 is factorable, but it factors as 12 times x plus 1, and x plus 1 wouldn't cancel with anything in this fraction, so we are done. All right, that's adding and subtracting fractions.